Hello, today we are doing operations with complex numbers. So we're going to learn about what an imaginary number is, what a complex number is, and then we're going to do basic operations such as simplifying, adding, subtracting, and multiplying today. So the first question I want to ask you is what same number times itself, so something times the exact same thing, like 2 times 2, equals -1. So I want you to take a second and think, what number times itself will equal -1? Sitting here thinking, well, you're probably thinking like, well, 1 times 1 gives you +1. -1 times -1 gives you +1. So it's not a number itself that multiplied by itself will give you -1. So because of that, we had to make up an imaginary number, which we call I. So there are no numbers that multiply by itself to get -1. So we had to make up an imaginary number. And like I said, we call that I. This imaginary number allows us to do I times I, and that equals -1. So now we have this value, this number that we multiply by itself, it gives us -1. So if we know that I times I equals -1, we know that I squared equals -1. If I take the square root of both sides, I know that I is equal to the square root of -1. So this is what I would call my key concept right here. All right, so I know I have I squared equals -1 and I equals the square root of -1. So I have those values now. So now what we're doing is we're going to talk about what a complex number is. So a complex number involves this imaginary number, this imaginary term, as well as a real number. And when we combine them to become a complex or a multi-part number. So a complex number is always written in this form. A plus BI, where the first term right here, that A value is your real number. So like 2, 5, 7, -1/2, whatever it might be. And your BI right here is going to be your imaginary term. Or your imaginary number. So here are some examples of some complex numbers. Some examples could include -2 plus 7i, 0 minus 4i, 7 plus 0i, so on and so forth. So complex numbers have those real numbers in front, your plus, your minus, and then your imaginary number afterwards. So why we utilize this is because when we have an imaginary number, the big thing is that when we have the square root of -1, that gives us that imaginary term. So beforehand, when we had answers where we got the square root of negative something, we just said no solution. And now it's no longer be no solution, we're just going to have an imaginary or a complex solution. So what we're going to do first, we're going to do some operations of just simplifying. So our first example here is the square root of -12. So we're going to reduce it just like we would before. So we're going to find the biggest perfect square that goes into 12. The biggest perfect square that goes into 12 is 4. So I can say square root 4, square root 3. But if I do 4 times 3, that would give me positive 12. And I want -12. So what I would have to do is I have to do the square root of -1 times the square root of 4 times the square root of 3. That's how I'd break up 12 there. I know the square root of -1 equals I, that imaginary term we just learned. The square root of 4 equals 2. And the square root of 3, we cannot reduce it, also just be square root 3. If I combine those, I times 2 will just be 2i radical 3. And that is simplified. That I again tells me that beforehand it was a negative value under that radical. So that would be our complex number there. I want you to pause this video. I want you to try the next one, square root of -32. Reduce it down, break it down so it looks kind of similar to the first example. All right, hopefully you try this on your own. When I broke down this one, I said it was -1 times radical 16 times radical 2. That -1 became I, the 16 became 4, and the radical 2 remained the same. So my final answer was 4i radical 2. And I hope you got that. So now we can simplify radicals. Next we're going to do is subtraction, multiplication, and addition here. So when I'm looking at this problem here, I've got 7 minus 6i minus 3 minus 6i plus 2i. So what I'm going to do first is I would distribute that negative through. So I have 7 minus 6i minus 3 plus 6i and that plus 2i. So now my parentheses are gone. You want to combine like terms here. So I would say some like terms are 7 and negative 3. 7 and negative 3 would give me 4. Then I have my imaginary terms. I've got negative 6i, positive 6i, and 2i. So negative 6i plus 6i, well, that would just give me 0. 0 plus 2i would just give me 2i. So plus 2i. And again, we want to write it in this complex form where your real number comes first and then your imaginary. All right, our next example here. 3 minus 2i times 5 minus 6i. So what I want to do first, I want to shift that negative 2i to that parenthesis. So negative 2i times 5 would give me negative 10i. Negative 2i times negative 6i would give me positive 12. And then I times I would give me I squared. So we're looking at this now, and I'm looking, well, I have to combine some like terms here. I don't see any like terms, so I have that 3, so my real number. I have the negative 10i, but then I have a 12i squared. So the I and the I squared aren't like terms here, but we do know what the value of I squared is. If you remember back at the beginning, our key concepts, we know that I squared right there is negative 1. So if I go back to my problem, I can actually rewrite this as 3 minus 10i plus 12. And I know that I squared is actually negative 1, which would make that value right there just negative 12. And now I can combine my terms. I've got a 3 and a negative 12. 3 and negative 12 gives me negative 9 minus 10i. So when you see an I squared problem, you can reduce that down. All right, my final example here is 3 plus radical negative 5 squared. So looking at this first off, I know that when it says squared, we can write it out twice. So I know I can write it like this. Oops. All right, so if I start foiling this out, I've got 3 times 3. 3 times 3 is 9. Then I've got 3 times negative radical 5, which gives me 3 radical negative 5. Then I've got 3 times negative radical 5 again. So 3 times negative radical 5. And then I have this, negative radical 5 times negative radical 5. So I want to take a little pause quick. I want to do a little key concept with you here of what that kind of means. So when we do a radical times a radical, the radicals cancel. So here's an example. If I do radical 17 times radical 17, okay, you get the square root of 17 squared. The square root and the square root cancel out. So my answer here would just be 17. So those radicals cancel each other out. What if I had this? I radical 5 times I radical 5. Look at this. If I do I times I, that would give me I squared. And I know radical 5 times radical 5 would just give me 5. I know that I squared is just negative 5. If I look at that, when I look at the square root of negative 5, that's actually just I times radical 5. So really, the square root of negative 5 times the square root of negative 5 would just get me negative 5. The radicals cancel each other out. So if I go back to my problem, the square root of negative 5 times the square root of negative 5 would just give me negative 5. So now if I combine like terms, 9 minus 5 is 4. Plus, I've got 3 radical negative 5 times 3 radical negative 5, which gives me 6 radical negative 5. And just as always, we don't want to keep that negative there, so we want to pull out that negative. So we want to say 4 plus 6i radical 5. And that would be my final solution.